So in this lecture, let's explore about the embedded target that is being used for this course. So in this course, the STM32F407 microcontroller based discovery board is used as the target. Now let's explore some of the important features of this board. So the heart of this board is actually the microcontroller, which is produced by ST Microelectronics. So the exact part number of the microcontroller is this one, STM32F407BGT6. So it's a 32-bit microcontroller and it is based on the processor ARM Cortex M4 with floating point unit. So this is a microcontroller, and after that to connect various external components such as LEDs, buttons, LCDs, keypads and various other things. So a rich set of IO pins are available on the board. So these are actually the IO pins, or what we call as external interfacing headers, IO headers. So there are lots of IO pins are available for your external components interfacing. And this board also has 8 megahertz of crystal oscillator in order to supply clock to the microcontroller. Apart from that, another important feature of this board is its onboard programmer and debugger. So this is one of the important feature of this board. So if you want to program and debug the code on this hardware, you need not to buy any external programmer and debugger. So the board comes with its own programmer and debugger, what we call as ST-Link V2A. So by using this onboard programmer and debugger, we are going to program and debug our code. So when you install the IDE, that is STM32Cube IDE, the driver for this programmer and debugger will be installed automatically on your machine. Otherwise, ST also gives the separate device drivers for this ST-Link hardware. So you can also download from the ST's website and you can install it. So for detailed information about the board, you have to refer to the user manual and schematic, which is given by the ST. So you can go to this link and you can download those documents. So I have given this link in the resource section of this lecture. So when you go to that link, you will find a section called resource. So just click over that and then it will display all the related documents such as user manuals and schematics. So just download it. So you need not to explore these documents. So as we make a progress in this course, I will show you how to extract information from this user manual and schematic. So just download it and keep it in your machine. That is sufficient. So how do you connect this board to the PC? Very simple. You just need one mini USB cable, which is as shown in this figure. So this cable doesn't come with the board. So remember that. You have to procure it, and then you can just use this mini USB connector of the board to connect to the PC. So now this board also has a micro USB connector here. So don't use that. So we don't use this in our course. So that's the only connection you have to do in order to start using this board. So that's about the target, and I'll see you in the next lecture. Alright, first let's learn some basic syntaxes related to usage of variables and some of the important standard library functions such as printf, scanf and all. And for this, I will not be using the IDE which I installed, okay? What I do is I use one online compiler called Online GDB, which is very much easy to use, okay? And it only requires internet connection. So you can also use this for a time being. Later we'll use our Eclipse IDE install to write programs, okay? Of course, you cannot program your target board using this tool, but you can practice some basic syntaxes of C program. But for any reason, if you can't able to use this online tool, then don't worry at all. you can use the IDE installed. Anyway, now you already know how to create a project, compile it and execute, right? Great, now let's get started. Hey, welcome back to the lecture. So now let's start with small. Let's first write a simple C program. Let's write a C code which simply displays the text hello world on the console and exits. And for this, I'm going to use the online IDE. And if you don't have access to internet, then no problem. You can always use the offline IDE. Let's head over to the IDE. And here, let me just create a new project. So now let's click new project here. So now let's click save in order to save our project. Let's give the name hello world and let's save. All right, so our project name is hello world, and under that project we have one source file that is called as main.c, which is added by this tool automatically. So now for some people you may not able to see this main.c. In that case, what you should do is you should go and select this language. So here you can see that the C language is selected automatically, but for some people it may not have selected, so that's why you have to select appropriate language here. And also if you go to the settings, so you can select the theme, dark or light, and editor mode, font size, and other things you can change here, and the compiler flags you can also modify here. Let's close this, and this is our main.c, and now let's delete everything. So I'm just going to press Ctrl A and I'm going to delete everything. Let's write a simple C program which displays the text hello world on the console. Alright, so please remember that every C program has at least one function that is called main function. So main is actually the starting point of your program execution. A C program is nothing but collection of various functions, and it should contain at least one function, and that is called as main function. So now let's write the main function. So don't worry about functions, its prototype and other details. So we have separate section for that to understand functions. At this point, it would be too early to explore all those things. So let's write a main function in our C source file. For that, just type the function name, that is main. And after that, you have to put the parentheses. So these are the parentheses. And after that, you have to mention the return type of this function. That is actually int. This is according to the standard. So according to the C90 and C99 standard, main should return int. So that's what standard says. All right, no problem. So this is a prototype of the main function, and this is a function name, that is main. And now let's give the body of the function. So every function will have its own body, and that is identified by these brackets. All right, so now what we just implemented is actually a function definition. So this is called as function definition, where it has the prototype at the beginning and it has its body. So now inside this body, we are going to write code, and that code will be executed by the main when the main function is called. And in this program, our job is just to print the text hello world. And in order to print something on the console, the C standard library gives one function for us, and that function name is printf. So printf, and this is a function in order to print some text. And it can do various things, but for a time being, let's use this to print some text. So write printf, and after that give the parentheses again, Alright, so and after that you have to mention your message in double quotes. So now let's first write the double quotes. So just write a double quote and the IDE will convert that into two double quotes because your message must be in between these double quotes. So that's what printf expects. So your message should be in between two double quotes. So now here let's write our message. So our message is hello world. So now in C programming, remember that every C executable statement should end with semicolon. So here, this is the body of the function, right? And in the body of the function, we have one C statement that is actually a call to the printf function with our message, right? And this is a C statement and it should end with semicolon. So otherwise compiler will throw errors. So that's why let's end this statement with a semicolon. So this is not true if you are coming from the background of Python, let's say. So in Python it is not required, but in C, C++, yes, every statement should end with a semicolon. Alright, so after that we need to do one more important thing, that is we have to include a standard library header file. Now about the header file and why we should include that and all those things we'll understand later. So in the later part of the course, we are also going to understand about the compilation process and various other things. So let's not worry about that. But remember that in this source file, we have used a function called printf, which is not written by us. It is given by the standard library of C. And the compiler should need to understand the prototype of that printf function. And the prototype of that printf function is written in a file called header file. And that header file name is stdio.h. And we have to include that file into our project. And now to include a file, you have to use #include directive. So now it is written something like this. #include. So this is a directive which is used to indicate inclusion of another file. And that another file name is stdio.h. This is written by the technical committee or the developers who develop the C standard library. So now, since it's a standard library header file, it has to be enclosed by these symbols. So this is a way you include stdio.h. So this is a include directive and this is a file name. And since it is from standard library, so you have to use this lesser than and greater than symbols. It is fine. So you can also include a header file which is written by you. So that is also possible, and more on that we'll see later. Alright, now let's compile and run our code. And for that, in this IDE, there is only one button which will compile and run your code. And you have to press this run button. Let's click over here. And here you can see that it is compiling and the output is produced and it is successfully printed the text hello world on the console. So you successfully completed the very first C application. Alright, so now I want you to do one small settings in this project. So go to the settings here and go to the compiler flags. And here just give hyphen and type save temps. So just write this compiler argument. So this is a compiler argument, save temps, and click OK and click done here. And after that, again run the file. And here it is. So it has created so many files. So these are the output files produced in the process of compilation. Remember that this is a main.c written by you, which is a source file which is given to the compiler for compilation. And the first file which is produced during the compilation is a pre-processed file. So that we call as main.i. And here you can see that main.i is nothing but the collection of your code. This is written by you and contents of the stdio.h. Now your main.c converted into main.i, which is a huge file, isn't it? So your file had only 8 lines, but look at main.i, it now has 849 lines. So what happened was here, so when compiler saw this line, that is stdio.h, compiler included all the contents of this file into this main.c, and then it converted that file to main.i, which is the output of the preprocessor stage of the compilation process. And here the compiler actually looks at the prototype of this function. So which is written somewhere here. You have to set that. So here there is no search option actually. So what I would do is I would just copy this contents, and here I will just search for printf. So which is right here. Just search for printf and just click on match whole word only. And here it is. This is a printf function called by you, and here it is. So this is a prototype of the function printf. So compiler wants this signature. So this is also called as a function signature. So that's the purpose why we added that stdio.h. So first main.i is produced, then after that main.i is converted into main.s, which is collection of assembly instructions. So your higher level language is converted into a little lower level language that is called as assembly language. So now assembly instructions are generated for your .c file. And after that, this will be converted into a machine code, and that we call as main.o. So this is also called as object file. So you can see that it is not possible to read the contents of this file because it contains the machine code. So more on that we'll see later again. And we'll discuss all these things when we actually do programming on our target. So that is our embedded target. At this point, I just wanted to briefly introduce the intermediate files. So all these intermediate files you can get by adding the compiler flag called save temps, and I'm going to remove that. So it is not required for each and every project. So that's about the very first application, Hello World, and I will give you a small assignment. All right, so now I will give you one assignment. So you have to modify the program what we have just written to print these messages. So in the first line it has to print Hello World, and in the second line it has to print today is a great day. So just try to think how you can able to achieve this, and you can use 2 printf statements, no problem. So just think how you can do this, and I'll see you in the next lecture.